Okay, hello everyone and welcome to this session, the Securing Containers by Breaking In session. My name's Simon Maple and I'll be taking you through this session. It's going to include a number of slides as well as some live hacking, so hopefully you should be able to see my screen already. Through the GoToWebinar control panel, you'll also be able to engage in the chat and also ask any questions you would like in the questions panel. This webinar is being recorded and we will be sending you the recording of this webinar at the end of afterwards when we email you more information as well. So let's go ahead and get started. And first of all, why don't I tell you a little bit about myself? My name is Simon Maple. As I mentioned, I'm the field CTO at Snyk. You're more than welcome to reach out to me on Twitter and email. I've given you my links down there at the bottom. A little bit about me. I very much am into community work. My background is in development, engineering, developer advocacy. And I did a lot of work within communities, building communities up, really all about sharing the knowledge, sharing the education, and growing that networking and encouraging people to collaborate and communicate with each other. My background personally in engineering is through development, is through Java, pardon me, and for better or for worse. So I've been a Java developer for over 20 years as well. Okay, so this session is going to heavily be focused in and around cloud native, and we're going to be talking specifically about containers. But first of all, I want to show you a range of different containerized or cloud native applications and where the areas of focus are that we need to consider. So when we think about containerizing our applications, or the journey we would go to in terms of containerizing our applications, first of all, where do we start? Well, we start really in this journey of bringing a monolith potentially over from a non-cloud environment and trying to base that onto a cloud platform. And when we think about that, typically the applications, the existing style applications that we try to pull over, they tend to be, first of all, very big. They tend to be potentially deployed on some large software platforms. In this case, we have an application, a number of functions within the application, sits on top of an operating system, which is in a virtual machine. Virtually all of that we would need to look after. So the cloud platform that this would sit on, it would abstract the hardware away, it would look after the network for us, but there's very little else that it would take away. And as we go through this journey from left to right here, you'll see the shared responsibilities and what us as a developer or someone who is in an operations style role needs to look after, and what the platform will take responsibility for. So next up after this, we go into the containers. And when we think about the containers, a lot of the responsibility then moves into this cloud platform. So we can see, first of all, we can still scale our host VMs, but within the host VMs, we have a number of containers that can equally scale. The containers contain much smaller pieces of function, potentially lending itself more to a microservices style environment, and the containers each have their own operating system. So this is much more nimble, as it were, because we can actually choose which operating system we would want to run each individual function on. Of course, all of this would run with some orchestration service running underneath, maybe a Kubernetes or something like this. The cloud platform would then take on a ton of other things, including, well, in fact, one of the big takeaways that we have here is actually the cloud portability. So we can actually much easier have many different cloud vendors, have containers that would typically drop in and out of the different platforms. Elasticity wise, well, we can scale our containers rather than our VMs. But more importantly, because the functions that exist in those containers are actually much smaller, we can actually scale our function. We think of it more from the business point of view. We can scale individual functions. So it's better from that point of view. But the things that we need to look after, the containers, the operating systems, the application, the container orchestration, there's still a lot of security issues and considerations that we need to think about, which are on our side, not the cloud vendor platform. When we think about serverless now, so going full on the trying to push as much as we can into the cloud environment and the cloud platform, we can see now what is actually more assets that we need to take care of, we're really looking at your configuration and your function. So we're talking about the code that you write and the config that will connect that up to cloud services and things like that, databases, etc. So what gets pushed now in the serverless environment is, well, the cloud platform looks after the host VM, looks after the operating system. We no longer need to think about what versions of operating system, what distribution, what levels that, whether it's pulling in enough security patches, etc. There's no hardware management, there's no OS management, as it says here. Cloud portability wise, apart from the configuration, our code shouldn't really be coding to a platform. It should really be very agnostic of the underlying platform. It's more the configuration which ties and connects our coding over to a specific database or whatever we want to use. In terms of elasticity as well, our function scaling is much easier than trying to scale a container or something. So this is the kind of flow that we have, and you can see the more we go right, the more that gets pushed down, and as a result, the more of our concerns, our security concerns, push down into the cloud platform. So we're going to be talking mostly about the middle section here, where the areas that we need to consider is the security of our containers, of our actual functions, our code, and talking about containers, the operating systems as well. So with this flow, we as developers need to think differently about the way we code our apps and what scope of our application development looks like. Pre-cloud, we typically looked at applications as a developer thinking, well, I'm going to code my own custom code in my own language. For me, that'll be some Java. I'll do that likely with Maven. So I've got a POM XML that's going to pull in a number of different dependencies. So I care about the code I write, my app code, and the open source libraries I pull in through my dependency management tool. That's all. In the previous method of software delivery, we used to, as we used to mention, this kind of like wall of throwing code over the wall. This is how we used to deliver to a platform team, to an operations team, and the operations team, the IT team, used to look after the hardware, the virtualization, the VMs that we were running on, and the supporting apps that go alongside that. Whereas in today's world, we think as developers much more about the operations side of things, but the deployment, the production environment, and that includes your containers and your config, etc. So as a developer, our scope of what we touch, the area, whether that's our own code and our libraries the same way as before, but also the services we connect to, the containers, potentially the images and the packages that we pull in within those containers. All of that now we need to think about, not just from a let's get it working, but also from a manageability, from a maintenance, from a security point of view. And this is the shift in which developers need to get into. So when we think about, and this is only going to go into a couple more slides before we jump into some good tips around containers. So when we think about the platform that we need to support that new scope of application, first of all, we need to think about the custom code that we write, and the custom code that we write needs to be statically scanned for typical security issues, and this is typically a SAST style approach to scanning that code. After that, the open source code, the dependencies that we pull in, these third-party dependencies contain probably the largest set of vulnerabilities that our application is going to potentially have, and the vast majority of our code base is in fact also open source. So typically, this is an area that we need to take a lot of effort understanding what we're pulling in, and that's the whole dependency graph, not just the direct dependencies, and then recognizing what versions, what vulnerabilities that exposes us to, and what code we're actually going through. Then we go on to the containers, because of course then we try and wrap this into a containerized bundle that we add as a workload. And the containers, there are a number of choices and decisions that we need to make, not just about versions, but about the type of distribution, whether it's a slim style, whether it's not. And this is going to largely depend on the needs of our application, but we need to recognize that the choices that we make here are going to determine what scope of packages we do pull in, and as a result, the types of vulnerabilities that we do get through them. And then finally, when we think about the infrastructure as code that we're putting in to perform these deployments in a reliable way, misconfiguration is one of the core issues that we see in today's cloud native environment, and also one of the highest concerns that we've seen from customers and prospects. And that's thinking about the code, whether it's Kubernetes config, whether it's Terraform scripts. And it's not always the code that we see which is the problem here. It's the code that is emitting, the config that doesn't exist, that misses some incantation, that seals up or blocks a path which could potentially provide attackers with a path in. We of course see many news articles about S3 buckets, for example, being deployed in an insecure way. It's all about the configuration of those buckets. So this is a good stack to think about when you're looking at your application: the code I write, the code I pull in, the container I deploy it in, and the infrastructure as code configuration that I'm using to deploy that container. Okay, so we're going to jump now into a number of tips to talk about how we can secure our containerized applications, and give some best practices and some advice as to some of the areas that we need to think about when creating these containerized applications. So here's the list, but I'm going to jump into these in a little bit more depth. Okay, so number one, preferring minimal base images. Now, our container images, effectively, we never start from scratch. We always pull in a parent image, and this is our from directive at the very top of that page. Now, our from directive, we, as someone who's trying to get something working, would tend to copy from another Docker image. People won't necessarily think, oh yeah, I know exactly which one I want for my application. They'll tend to go, okay, which, our development teams, they're not operating system specialists or anything like that. It's easier just to go, well, what was my last one? I'll just use that same one. Okay, so it's about just getting a platform that you can deploy your application onto. So one of the things we need to do though is think a little bit more carefully about what we choose. And one of the good piece of advice here that I'll give is that we've seen very much in the past from a number of our customers is for the security team to offer specific base images that have been truly tested, that are slimmed down, that is appropriate for the different types of application that get deployed, and for developers to then be able to choose from those. And as they add to that stack, the responsibility split between your security team that are providing these base images and your application team is quite simple. The security team looks after the vulnerabilities that are provided in the base images. So anything that the security team says this is an image, a containerized image that you can use, the security team take care of the vulnerabilities in that image. If developers put any more vulnerabilities introduce any new vulnerabilities either through packages or anything else that they install or deploy onto that container, that's the responsibility of the developer to do. So we have guardrails. We're talking about empowering developers, and we do that through guardrails. So preferring minimal base images is a great way, and whether this is done by the security team or the development team, entirely up to your organization and how the dynamics of your org, but making sure the base image is small enough that you're not introducing unnecessary vulnerabilities through packages that you actually don't need on that system is important. And when we look at the number of OS vulnerabilities by Docker image, let's say here's a scan which hasn't actually changed that much, although it's a couple of years old now. This example, in fact, I think the number of node vulnerabilities has indeed increased since this. But these are the official images on Docker Hub, and you can see the top 10 most popular images on Docker Hub have at least 30 vulnerabilities, and the node one, of course, there a vast number more. So this is just to kind of give, and of course not all of these are exploitable or reachable necessarily through your application, but it's important to understand that these images don't come vulnerability free. These most popular ones aren't free of vulnerabilities. So picking that is very, very important. Number two, use the least privileged user, and this is a good security advice in general about providing as least privileged or the fewest privileges as you can for the application to work, and no more. So that if breaches, or sorry, should I say hacks, do occur, you provide an attacker with the minimum access, privileges, and tools that they can have at that stage, and no more. So least privileged user is about when we think around what the user is that the user directive, in fact, in the Docker file, which user we choose in order to run that as. Now, if you don't have a user directive in your Docker file, your Docker will automatically run as root. A lot of people know this, some people don't. A lot of people don't even check whether they have the user directive in. So it's important to, first of all, create your own user or group. In this case, you can see that I am creating a user with no password, no home directory set, and then we add that into a group that we also create beforehand, just using the group add command there. And what else are we doing? And then we just add the username there and add it in association with the group that we just created. Very, very limited user. We can also actually reduce things in the system, perhaps some of these system utilities on the operating system, so that as a user you don't even have the system utilities that you might want to call as an attacker. So reducing what you can call, but just reducing privileges is an excellent way of limiting the damage if someone were to hack in. The node on Alpine image has a really interesting user here that comes by default, node. So if you are a fan of node and Alpine images, you could make use of this generic node user out the box as well, just as a note. Okay, so signed and verified images to mitigate man-in-the-middle attack. So a man-in-the-middle attack is where you could potentially have a malicious person or a malicious somehow between the publisher and the consumer have this intermediate step where someone who is malicious might mutate the content that goes between the two parties, such that it could be listening, it could be just peeking into what is being sent, but it could also be altering. This is potentially dangerous because you as an individual, as a consumer, you want to make sure that what you're getting from your source is exactly what the producer put there, and not something which someone is trying to add listeners in or trying to potentially damage your data. So it's important, as we want to put trust in these images, that we make sure it's from the right place. Now, to do that, one way you could do that is through Docker Notary, and this is directly from Docker, and it actually provides us the image signature directly, and indeed it blocks you from running an image if the signature of that image is not valid. So here you can see these Docker certified images are all images that have the signatures, etc., and you can these are signed images, and you can very, very easily check that using Docker Notary and make sure that it's not just a verified publisher, but it's a verified image that you download as well. Couple of other things while we're talking about signing. These are just the docs if you want to get started. And of course, actually, I think these are the old docs. There's a Notary, there's a version 2 of Notary which is out as well, which you should check out. But one thing as well, the export. There's just this brute force way of doing it. Docker content trust equals 1. If you export this environment variable, then when you try and pull an image which isn't signed and validate and verified, then that pull will fail. So this is just a nice little way to just to see if the images that you are using in your particularly in your automations, as you run your automation with this set, you'll see exactly what's signed and what's not signed, and it's something you can check very, very quickly. Okay, next, thinking about the find, fix, and monitor open source vulnerabilities in the operating system. So what we're talking about here is scanning your Docker images for your vulnerabilities that exist in your packages for your operating system. Now, when we did our survey here to determine when people test, it's surprising how many people didn't test their Docker images at all, but most people will tend to do it between build time and development, really, which is great. That's a good time to be able to do that, because it reduces that feedback cycle time. You want to find issues early, you want to test early, and you want to fix early. So doing it early is good. It's sad to see the we don't so high. And by the way, this is a multi-choice, which is why the numbers add up over 100%. So people are doing it at multiple times as well. Now, in terms of scanning your Docker image, in fact, this is a slightly old CLI command as well. You can do a Snyk container test these days. But in terms of scanning your Docker image, you can do it at the command line. You can do it also at the in the registries as well. And in this case, what we're doing is we're fetching an image to be tested, and we're scanning that on the command line with Snyk. So we can do a Snyk container test, and that will automatically test the Docker file. It'll look at in fact, this will test the Docker image passing the Docker file as well. It'll take a look at all the layers, it'll take a look at your Docker file, and it'll find issues that exist within as known vulnerabilities. One of the other things here is, how do we find out about new vulnerabilities in your deployed container? So this isn't about scanning an existing container through a pipeline before we deploy. This is about a deployed container that we know what's in it, we know the image, we know the package, etc. But what if a new vulnerability exists and we want to be notified of that, and we're not going through the pipeline, so we're not necessarily going to be notified by our CI or during development. So how do we find out about a vulnerability that exists somewhere, a new vulnerability in production? Well, most people actually, in fact, won't. A lot of people use scanning tools, as we can see there. Some people more manually track public databases, and around 1 in 5 rely upon the security team, who potentially do one of those other two as well, either tooling or databases. So one of the things that we can do here is use the monitor piece of Snyk, and I'll show some of these in our demo a little bit later. But the monitor piece allows us to effectively continually scan every single night, looking at the same image effectively. And when a new vulnerability comes in that affects one of our existing packages within that scan, we'll automatically get notified of those issues through our choice of communication. This will also provide us with the ability to actually view the results directly in the Snyk UI if you chose, whereas with the Snyk test, that provides you with the data at the command line, whereas Snyk Monitor provides you with that snapshot in the UI, as well as that continual monitoring of your Docker images. Okay, so obviously we scan a fair number of Docker containers as well, and so here are some Snyk insights from our data. Last time we did this report, we checked how many Docker images were out of date with our newer images. Now, let's take into account here as well that newer images might not contain security vulnerability fixes, of course, but by not being on the latest or not being close to the latest, we're more chance of not being on consuming those security patch. So 44% are actually on or could have upgraded to a newer, more secure base image. 20%, so 1 in 5 people, can reduce the number of vulnerabilities just by rebuilding the Docker image. And this is a really interesting question about how organizations also deal with images in terms of keeping up to date. In fact, there's a really good podcast on the Secure Developer in which Guy Pajani recently interviewed Justin Cormack from Docker CTO, and there's a really good discussion about whether or not people should get notified of new images, and whether people should actually stay on the latest image or only upgrade if a security issue exists. And there's some good discussion there, so I do recommend checking that out. But a lot of the time, by performing a rebuild of a Docker image, you'll actually pull in newer packages that will consume security issues as well. And a lot of the time, it's actually as simple as just doing a rebuild to pull in and consume the security patches from the packages that you're pulling in. So that's very similar to app, particularly in more package managers that don't pin versions as much, such as a node or something like that, where you have more ranges. Rebuilding can very often eliminate security issues through there. Okay, so we're going to take a look at one issue here. And this is an issue which exists in ImageMagick. And ImageMagick is a package that allows us to do a number of different things with images, image manipulation tool. And it's fairly well known for a number of different vulnerabilities, but the one we're going to be looking at right now is going to be the improper input validation. So this is the vulnerability, and you can see the CVSS score on the right-hand side, where it's a high SEV vulnerability, and a little bit of information there. So let's go and check this out. And jump across. Got a couple of questions just coming in that I'm happy to answer as well. Sorry, I haven't been able to see these until I stopped screen sharing. Okay, so yeah, a couple of questions coming in. Many of the base images contain known vulnerabilities popping up in scans, but aren't necessarily a security issue. Now, yeah, this is similar across operating systems as it is applications, and it's important to make sure that first of all we at least know about them, but secondly to understand how we triage them. And I think if there are security vulnerabilities that exist that aren't necessarily a security issue, perhaps we are absolutely confident that this isn't being exposed in our environment, or perhaps I don't know, perhaps it's just for whatever reason it's so hidden you can't even access it, or whatever the case may be. There's a couple of ways of dealing with this. First of all, our recommendation really is if a vulnerability exists and you can get rid of it easily by eliminating a package or upgrading a package, even if you're not using it, it does make sense to do that anyway. As you know, it can reduce maintenance or further security issues in that type of package later. And if you're not using it, you might as well eliminate it. It's like the least privilege, but instead of with permissions, it's with reducing the scope of what you're deploying. However, in this world that we think about, we don't really, when we have hundreds, thousands, tens of thousands of, or whatever of vulnerabilities, it's more about a prioritization issue. So we'll talk about prioritization in a little bit, but I feel like one thing that we can use is potentially use things like ignores and things like that, so that we can reduce the noise of vulnerabilities that we know that we have good confidence that aren't affecting us. And this does two things. I mean, we don't want to constantly and overuse ignore too much, but if it's reducing the noise such that the number of vulnerabilities or the specific types of vulnerabilities that developers can look at and try and fix, it makes it a lot easier. It's very similar when like with my kids, if I give them 10 slices of pizza, they are going to eat less of that pizza, fewer slices than if I give them one at a time. And it's a method which is used a lot by, I think, parents and maybe engineering managers, I don't know. but by limiting what you provide someone with, it focuses them on that one thing, and they're quicker at doing that one thing. So if you give someone a huge backlog of issues, then yes, they're going to be overwhelmed, they're going to do fewer of them. But if you actually produce, just give people sight of what they need to do that sprint or etc., then they can do that. So that's one option. Does Snyk require Docker to scan the image? No, so you don't have to. On the command line, actually, that's a good question. On the command line, I'm not sure. So you might need the Docker image there locally on the command line. But I know if you're doing anything through Docker, through the registries or anything like that, you won't need any Docker at all. It'll actually do it all using SaaS tooling, or if you're using on-prem, you can do it entirely like that. So you wouldn't need that locally. Will Snyk scan the images without the package manager? So you do need the package manager there, because that's what we use to recognize the versions. There are a number of key binaries that we will also scan. So we will look at that using some fingerprinting techniques to understand whether it's Node or whether it's the JDK or something like that. And we will look at the vulnerabilities that exist in that known known package. There's a few more questions coming in, which I love. I'm just going to make sure that we cover some more content before I jump to those questions, but I will jump to that now. Okay, so what I'm going to do is I'm going to jump across to an application that exists here. This is an application which was running in a Docker container that has that image tragic vulnerability in the image magic package. Yes, the vulnerability is called image tragic, which is very it's a nice vulnerability name. So in this case, it's just a simple application. I'm going to grab an image like this, and I'm going to choose this file. And if I go to my recents, there's my screenshot. Let's grab that file. And if I click resize, what it simply does is it just resizes that image to this Twitter size image. So if I click that again, I can choose another one, and it pushes it to that, as you can see, that 280 by 150 resolution. So I'm going to choose a different file this time, and this file is, if I jump over to my SJ Maple, let's go into Snyk, let's go to the container breaking in, exploits, and RCE1.jpg. This is going to be a remote code execution. And this is just a JPEG, so this is a regular file. Now, before I click resize, let's take a look at what that looks like. I'm in that same exploits directory, and I'm going to cat rce1.jpg, and you'll see, in this case, what we do is we grab a URL, but as part of that, we actually break out and we do a touch of RCE1, the file RCE1. Now, I am in the Docker container here as well, just as a terminal. And I just want to show you here, there is no RCE1 file. But when I click resize, this is as part of that image being loaded and being evaluated effectively by this image magic. We're going to run that touch locally. And if I click resize, you can see we've just got a dummy image there. But if I come back here and take a look again, we have the RCE1 file. Oops. We have the RCE1 file that was created today at 3. Okay, this is in Central Time, but that's fine, Central European Time, pretty much now. Okay, so that's our proof of concept for a touch. The next thing we want to do is let's do something a little bit different. I'm going to upload a new file, but this file is called RCE2.jpg. Now let's take a look at what RCE2 does. RCE2 I'm in the I'm on the Docker container still. Let's have a look here. So let's clear that and cat RCE2.jpg. Now in this case, what we do is we're doing some image over logic, and when we do an image over, this little backtick here means that this text will get evaluated. Now, when we evaluate this text, we're going to perform a wget, which is going to pull from a location, and this internal 5000 location is my laptop. I just need to make sure I'm serving content off of that port, and we're going to pull down a file called r.sh. We're going to pipe that into a local file called r.sh, and then we're just going to bash that file, and then for no reason at all, we're going to touch another file called a. But this is the key point. We're going to run that file. So let's cat r.sh, which is here locally, and what we're going to do is we're going to wget from the same location Netcat, and we're going to extract it. We're going to make it, build it, and then we're going to run Netcat and try and talk on a specific port 3131 with, in this case, my local machine, but it could be any server, of course, and try and reach out. So there's a couple of things I need to do in order to make this work. First of all, I need a Netcat listener, which, as you can see here, I'm going to be listening on port 3131. So there's my listener. The second thing I need to do is, if I was to show you that we're in this directory where we have the netcat zip and r.sh, I need to serve from this directory. So this is now allowing people to reach out and pull from my local host on port 5000, and people can grab these vulnerabilities. Okay, next thing we want to do is effectively resize. So what this is going to do by clicking this is we're going to pull across the rc2.jpg. We're going to try and do some execution on that to build up the JPEG, but as part of that we're evaluating a wget, pulling across Netcat, extracting it, building it, running it, and connecting to my Netcat listener, which is running on my local machine, and then that should act as a reverse proxy after that. So I've clicked resize, not a lot is happening, and that's because all of those things are happening in the background. So if I was to go back over here and do an ls-1, you can see a number of things. So we've had some output being logged. You can see Netcat is here and it's been extracted and likely built. You can see r.sh exists there. A hasn't been touched just yet, but we're still running, so that's all fine. And if I was to jump back over here, this should now be connected to my Docker container. So now this is running as a reverse proxy. So now I can perform an ls, for example, and now I have access into that. I can decide a whole bunch of things just to type in. I'm obviously root here, so I can have a look at some processes. I can execute some stuff. So this is a neat little attack into a package, an operating system package that potentially isn't needed, potentially just needs to be upgraded. There are ways around upgrading these packages. Okay, and in fact, as I cancel out of that, I wonder, I think here, if I was to do an ls, now there should be an A. There it is, because I just broke out of that that listener. Okay, so let's jump back into some slides. For some reason, I've lost my slides. Give me just a second. There we go. So we're going to jump through some other scenarios. One really important thing is to use a linter, and linters are excellent at being able to find misconfigurations and things like that. And a couple of these exist here. So what do we have here? Instead of using apt-get install, use apt-get install with a specific version on your package. So pinning, this is an interesting another one where some people choose to pin, some people like the packages which could potentially contain security vulnerabilities as well. It's more about that reliability of saying, if I build something right now in my CMI environment, I know it's going to be the same environment as the one I've deployed, and equally, if there's an issue in my production environment, I want to be able to build exactly the same version of that in my local development environment, so I can test and I can do replicate different issues, etc. There's pros and cons either way, which is why there's always a split camp on that. Other things like using copy instead of add gets around a couple of security issues, etc. But HaloLint is a good tool if you wanted to look at that as well. Okay, if we're in a container, that doesn't mean we actually break out of the issues of the open source vulnerabilities. So this is more in the application, but as we deploy our cloud native application, it's all really one and the same thing as part of our workload. So thinking about the open source vulnerabilities that exist, and I always look at container and our application SCA scanning as actually being very similar in the sense of we have artifacts that explain to us how the dependency graphs grow. We tend to have a number of direct dependencies that grow a dependency tree structure, and our code is actually fairly small in terms of the overall application. And one of the reasons why this is an area that is equally being targeted, there are a few reasons in fact, but one of them is one vulnerability also means many victims. So if you do find a vulnerability in some open source code that you can exploit, it's very easy to find various different instances of that on the web. But one of the other reasons is it's very easy to find known exploits, exploit DB or something like that, to be able to actually reuse exploits that people have already made and just try and find websites and applications that are susceptible to those exploits. So let's take a quick look. And in fact, in this case, what I'm going to do is I'm going to jump across to Snyk, and within Snyk, here we go. I'm just going to log in to Snyk, and we're going to do a quick import of an application, and I'll show you the various levels of testing that we're going to do on this. So I'm going to jump across over to my GitHub, and from GitHub, I'm going to import. Let's import. Where are we? Console. Oh, here we go. Goof Kubernetes. There we go. That's the one I want. So I'm going to add the Goof Kubernetes application into my dashboard. And what that's going to do is it's straight away going to start scanning that in various different ways. So if I click on View Log, you'll see the things, the pieces of the application which is already found. And in fact, it's found quite a lot already. So it's found some supported codes for custom code testing. It's found a number of YAML files and JSON files which it can scan for configuration. It's found a package JSON already, and these are, by the way, these are already scanned. And if I refresh that, it'll probably find the Docker file. That it's the whole application has already been fully scanned now. We've got a Docker file, so we now know the vulnerabilities that exist in our packages. We've got a package JSON, so this is the source code analysis of our application. YAMLs and JSON, which is our IAC, and Snyk code, which is our custom code. This is more of our SAST. So let's jump into some of these. Let's view SAST first of all. SAST is trying to find issues that exist in our code. So we look at our code and we provide information as to why these are command injections or SQL injections, etc. So in these cases, this is about allowing. This is about submitting, in this case, the HTTP request body flows into find. So this is being used in a SQL query, whereby we're not sanitizing this username at all, and as a result, you can easily get an SQL command vulnerability, SQL injection. Very similar here. The URL, the code here in URL could potentially break out of this and execute its own command within this exec block. So this is a command injection vulnerability. So these are this is Snyk code, which allows us to scan our own code. If I go back to my projects and let's go next to the package JSON, this was the next tip, which is about looking into the dependencies that exist in your application. And when we talk about vulnerabilities in your application, we first think about the dependencies, and these are actually just the dependencies that contain vulnerabilities or license issues. So you might have a direct, for example, Dust.js linked in here that has a high sev vulnerability. You might have transitives. So in this case, if I open up EJS locals, this has a sub dependency, a transitive dependency just on EJS, which has a high sev and a medium sev. I can also just look at all dependencies or just those with vulnerabilities or license issues. We care a lot about remediation, so we care about upgrading versions to eliminate more than one vulnerability. So here we have a number of different vulnerabilities. Each of these can be, or should I say, all of these can be resolved by doing an upgrade from a specific version to another version. But each of these doesn't need this version. Likely only one of them does. The others, I know, for example, the directory traversal, which why don't we fix that one right now? The directory traversal needs to jump only up to 0 to 5. But if we think about our package as a whole, we can eliminate more than one at a time. Now let's have a look at our issues. Now this is a good way of looking at our overall issues, whereby we can see a number of different things, including the severity of it, what the vulnerability is, a number of some information about the types of vulnerabilities, the CVSS score, the priority score, which is a Snyk priority score based on the severity of the vulnerability, which is based on CVSS, as well as the whether a fix is available, whether exploits exist, etc. We provide you with where it's introduced, how it's introduced, and what the fix is. So what version of either the direct or to fix a vulnerability in your direct dependency, or which version of your direct dependency you need to go to fix or to pull in a non-vulnerable version of one of your transitive dependencies. So if you have a vulnerability in your transitives, the fix is to upgrade your direct to pull in a minimum jump of your transitive that provides the fix for that vulnerability. So let's do a quick hack let's do a hack on a directory traversal. So this is a vulnerability that exists in the ST library, which is a medium sev vulnerability. We can see the fix goes from 024 to 025. It's got an exploit. It has a priority score there, which is based on the severity, the CVSS, etc. Now, what we could do is we could fix a vulnerability here just by clicking fix this vulnerability. And what this is going to do is runs a little test just to make sure this vulnerability still exists, and we'll also look at all the other vulnerabilities, and we'll only select the one we actually want to fix, which in this case is this ST one, and we open a fix pull request against the repository that we pulled this in from. And because we pulled this in from GitHub, that's what we're going to open it against now. Now this pull request is going to jump up to the minimum version we require to fix that vulnerability and no more. So this is going to jump up from 024 to 025. And that jump, if I click on here, that jump will also be tested. There we go, 024 to 025. Now that jump will also be tested because we imported this in from as a project from GitHub. We're also going to test, and all tests have passed here, to see if the delta change in this pull request introduces any more license issues or security issues. So we do those tests as well. Also, by pulling that in, importing that project, we're going to be testing nightly. So if a new vulnerability, and this is very similar with containers as well as it is applications, when new vulnerabilities exist, we don't need to go through a pipeline. We don't need to test manually. Snyk will automatically test nightly and inform us either through pull request or through a Slack message or through an email or however we choose with the remediation advice as part of that. So we have just over 10 minutes left, which is just about enough time to hack this application. So why don't I, if you wanted to, should we hack this? Let me see. Yeah, let's hack this. Why don't you hack this with us? Let's jump across to the application, which I have here running in a Docker container. I'll give you a couple of hints because we're running out of time a little bit. So I'll give you a couple of hints as to where this hack occurs. But this is just a regular, if I buy some milk, for example, it's a regular to-do style application. Now we have this about page, and this about page has this public about HTML, which we're serving from the ST library. Now let's go across over to a browser, not in the Docker container. Let's just go anywhere really. Let's curl this URL, and you can see here we get the HTML for that. So my question is, and feel free to just answer directly in the, I think only the Q&A works. If the chat works, feel free to ping there, but feel free to ping in the questions in the Q&A as well, some of the answers here. If I was to exploit this with a directory traversal, how would you try and exploit this? Okay, that's my question. So feel free to put your answers in, and while you're doing that, I'll give you a little background as to what a directory traversal is. Directory traversal is where I might have access to a specific folder on a server somewhere. So in this case, public, and a directory traversal is where or rather, this application should be giving me some access to some files in this public directory. However, a directory traversal is where I can break out of that directory and access files, access parts of the file system that are private, that I shouldn't be able to have a privilege or to see, etc., or permissions to see, should I say. So how would you go about trying to perform a directory traversal on this site to do that? So we have one. So we have a number of oh wow, lots of people asking the same thing, which is to effectively just do what you were doing on a lot of people want to see the etc password, which is great. The .. is effectively what we would do to traverse, right? We're trying to break out of that public, so we want to do the .. to get to that parent. So I perform that, and what do we get? Well, you can see this is the home page. You can see, hopefully our buy milk is somewhere. There it is, buy milk. We hit the home page, and we hit the home page because the ST library is a real world library that serves static content, and as a result, it needs to recognize what a directory traversal is. So it is recognizing the characters .. and it knows that is a directory traversal and is therefore denying us couple of other points. Doing lots of dot slashes. We can do a whole ton, but we'll still jump to the home page because we're not, if you think about what we're actually doing, we're not just, by doing a dot slash, we're not just getting back to this, right? What we're doing is we're trying to send the public dot slash to our library, which is inspecting the file system. So we're trying to break out and run and still get the results back there. So my question is, how can we do this? How can we do similar, but without using a dot slash? Is there a way to circumvent the sanitization, but still get the dot slash? Any thoughts on that? Okay, we have a couple of other options that are coming through. One is to use this, a tilde, which won't work. Any other thoughts? We're right on the dot slash. But is there another way of representing that? We can try private. Someone asked just to do private, and we can't do that, which could potentially lead us to another endpoint anyway. Use the hex values of the characters, someone just said. So using hex values is a great idea. There's another, you're really on the right lines here. It is ultimately an encoding issue, right? Because what we're trying to do is to see if the library that we're using is trying to look for a dot slash, or whether it's trying to, like specifically, or whether an encoding will get us around. We have the right answer, Luke. URL encoding, exactly that. The URL encoding for a dot is a %2e. In fact, many of you will probably have seen a %20 instead of a space in a URL. So that's another way of doing that. So %2e will provide us with the URL encoding of a dot. So if I was to run that, now we avoid the sanitization, and you can now see the public directory. We're out of the public directory, and this is where the public directory lives. So any other thoughts on how we can get further with this? What can we see? Everyone wanted the etc password, right? Let's see if we can get to that. All the way. And there is the etc password of the Docker container rather than my local one. Maybe a shadow would kind of be a little more interesting, potentially some hashed passwords there. So there is our hack. A couple of other things. Let's jump back into where was it? Here probably, there we go, into Snyk. And I want to jump back into my projects, but I showed you how we can do that remediation. A couple of things while we're still here. I want to show you also the UI piece of the Docker file, and then we'll jump into some of the deployment as well. The UI piece of the Docker file is really interesting because one of the things that we try and do here at Snyk is not just provide you with the issues that you have, but also how you actionably go and try and fix those issues. Because otherwise, if a developer needs to do too much more investigation and trying to find out how to fix these things, they'll easily find something else to do. We want to make it as easy as possible for a developer to actually go ahead and try and fix. So really empowering developers to know what to take for the next step. So you can see here that we're on a specific base image, in this case base image of node 8. You can see it has a significant number of vulnerabilities with the breakdown across there. You can see what the differences a major upgrade or a minor upgrade or an alternative image in this case will have on the number of vulnerabilities, plus how that affects the severity of those issues. We like to make them actionable, so you can also open fix pull requests to upgrade those base images or parent images. You can also see everything that you saw before, including the number of issues, the priority based on CVSS score, where issues are introduced, as well as the fixed versions that you need to jump up to in order to eliminate those vulnerabilities. So again, you can do your searches, you can change your priority score so that you can only view those issues that you want to fix, etc. So this is one way of looking at this. There are a number of integrations in which you can kind of pull this in. You can do this from, in this case, GitHub. You can also do this from Docker Hub and a number of other container image repositories. You can also do this from the command line, as I showed you previously, or in CI and a whole bunch of other places. In the last 5 minutes, I just want to kind of show you one more piece, which is an important piece around our YAML or our config testing, which in this case is very often things that are missing rather than things that are misconfigured in our environment. And this could be, for example, let's try and find an interesting one here. Here's an interesting one. So we have in this space just here in this step. We are potentially running without root user control. The container could be running with full administrative privileges, and this is what you need to do to fix it. So we provide you with what the issue is, where it is, what the impact could be, followed by the resolution step that you can add as a developer into here to eliminate the security issue there. This is a really important thing because very often, you know, we might not know to add this in. We might not know to set a root, to set a user in a Docker file, etc. So it's important to know what is missing as well as what's there to make sure that we're fully secure. Okay, I've only got a couple of minutes left, and I've got a couple of slides that I wanted to kind of like finish up with. There we go. A couple of slides that I wanted to finish up with. One of the last tips that I'll kind of like give is in and around using multi-stage builds, which is I think more of a multi-stage builds are kind of more of a secret than they should be really. And this is for reducing the image size based on any pre-processing or anything that you might do before you want to push that Docker image across to a container image across to your production environment. So if you take a language such as, in fact, what's the language? Oh, okay, we give Golang as an example here. You can very similar with Java or other things. If you have a large image A here, you have a large image size, and perhaps there's an amount of things in here that are really only used to build your application or build your environment up. Could be compilation or whatever it is. You may not want to go into production with those images. You may actually only need that to build your image. So we need to make a distinction here between what we need to build that image and what we need to in order for that image to run. And it may be that you might want to use the JDK still in your runtime, but that needs to be a conscious decision. That can't just be something that happens. Might be for tooling or a whole bunch of other things that you might want to use. Image B here is a very thin image that only contains things that we do want to expose, that we do want to exist in that image beyond building up to the required level. And the steps that need to happen in order for this to occur is we effectively mark things as you know, something that should be propagated into the next image. So we have these multi-stage images whereby what we deploy now in B is going to be a thinner image to what we deployed in A, because we don't need those extra packages, steps, or libraries required. Okay, so those are the 7 steps in summary. I'm thanking you very, very much for all of your attention and everything that all the questions and things. There are some of the whole ton of questions that I didn't get to. Unfortunately, we ran out of time. A couple of things I can get to very quickly in the remaining minute. But just to remind, this will be sent out afterwards as well. You can feel free to try Snyk as well. Go to snyk.io. We have a freemium tier as well as different levels of paid tiers. So you can go to snyk.io and try out everything I've shown you pretty much, and do that for free without trial. Just go ahead and try that. So I'll drop it over to here. Feel free to ask me any questions, reach out as needed, and I'm happy to answer them. But we have about 30 seconds to a minute left, and I'm going to answer a couple of final questions. Question here coming in: are you using third-party SaaS depending on the language? So right now with the SaaS tooling, we acquired a company last year called Deepcode, and Deepcode was a very, very interesting solution to us. Originally in and around static testing for code bugs, like fixes. It uses really revolutionary techniques and really scans extremely fast, as you saw. In fact, it was typically the first test to come back. And we're adapting that into a security scanning tool, a SAST tool. Right now, we're supporting Node and Java, and we're going to be, of course, adding all our usual languages in time. But that's what we're using currently for that. Thank you very much for your attention, and have a wonderful day.